Hello everyone, we will now see our next tutorial, that is abstract model simple. So there are two ways or two approaches by which one can create the abstract model file. So first one is one-to-one abstract model file creation, and second approach is many-to-one abstract model file creation. So one can do the authoring by any one of these two methods or two approaches. So let's see the first approach, that is creation of abstract model file with one-to-one approach. Now one-to-one means assigning one class to one component. Let's first understand the schematic of abstract model file. So you can see here there are two examples shown. So first one is the coupling assembly and the second one is cube over cube assembly. Now in this coupling assembly, the physics is we want to constrain the bottom face of this bottom plate and we want to apply the load at the center of this pin structure. Similarly for this two cube assembly, what we want or what exactly the physics is, we want to apply the load at the center of this top cube and we will be constraining the bottom face of this second cube. So this is the physics. So likewise every problem or every assembly will have some kind of loading, some kind of your constraint and some kind of physics or the some kind of parts which we want to evaluate. So for that, if we try to have the schematic of abstract model file, then all of you know that in the abstract model file we use the abstract classes. So all of you know what exactly the classes are. We have seen the details in our basic training. So classes are the entities which are not having any specific shape but has some kind of specific dimension. So these abstract classes we can use to represent our physics. So for example, I can create a load class just to capture my load related physics. I can create maybe fixed 2D related class to capture my constraint related physics, and maybe a solid class to capture the parts which I want to evaluate during my analysis. Similarly, all of you know that we are using the attributes in which we will be putting all the necessary input required for the simulation. So for example, in this schematic you can see this triangle represents the attribute. So load is one of the attribute which I'll be specifying on my load and the solid relation. So whatever relation would be there between these two classes, I will be specifying the load attribute. Similarly, node output attribute I'll specify on the abstract class, that is on the solid. Boundary attribute on the relation between my solid class and fixed 2D class, and there are some attributes which I'll be specifying on the solid class just to capture the physics related to my model. Similarly, there are some attributes which we will be specifying on the model or the global class. So those are basically related to mesh, material and the length scale factor. So likewise, your schematic or the abstract model schematic, it contains the classes and the attributes which will cover the physics related to that problem. So for this coupling assembly, we know that we want to constrain this bottom face and we want to apply the load at the center of this pin structure, and we want to capture these parts because we want to evaluate all these parts under this loading. Then my abstract model schematic will contain some relative classes, that is load to capture my load related physics, solid to capture the parts which I want to evaluate, fixed 2D to capture my constraint, and it will contain some attribute which will capture the physics related to my problem. So this is the abstract model schematic, and we can have the schematic if we know the physics related to our problem and we know the classes and the relation on which we want to specify that physics. You can see here I have opened the coupling assembly in Creo, and you can see here we have added the necessary tags on the CAD parts. So if you see here, we have used only one class against one component. So we have used solid class for the bottom plate, right hub, left hub, and the pin structure, whereas we have used the load class for this load part. So this is the tagging we have done for this one-to-one approach. Let's now see the details related to abstract model file. You can see here I have opened the abstract model file. So you can see here are the necessary classes, necessary relations are created, all the attributes related to physics is specified here. Now everything is based on the schematic of abstract model file. So you can see here we have used the model, load, or the solid class to define all the attributes related to meshing. Similarly, under Solution Strategy tab, we have specified the necessary attribute on the global class. Same applies here in the problem definition. So we capture the physics here with the help of solid, load, and the model class, as well as we have used the global class for the material. You can also notice that we have used the relation between load and solid to capture the loading related physics. Similarly, in the output tab, we have asked the necessary output with the help of displacement and the stress attributes. So this way, with the help of classes, we have specified the necessary attribute as per the abstract model schematic, and we have used or we have assigned single classes to single parts and tried to create the respective abstract model file. Now all of you know the next steps, that is we create the simulation model by clicking on this icon. After that we'll just select the coupling assembly here. Once done with the simulation model, we'll just carry out the meshing. So all of you know that the meshing will happen based on your meshing attribute. So you can see here the simulation model is now ready. I'll just create the mesh now. You can see here mesh is ready, and all of you know that after meshing we just carried out the export of our input text. So I'll just put here coupling assembly and I'll just select this folder. So this way what we have done is we assigned a single class to single component, and we use the class or those classes assigned to component in the abstract model file, and we specified the attribute to capture the relevant physics. And the next steps, that is simulation model, meshing, and export, that all of you know we do in the CAENexus workflow. So that we have carried out and we have generated the input data. So this approach of creation of abstract model file with the help of classes, that is one class assigned to one component, this approach we call it as one-to-one abstract model file creation approach. Let's now see our second example, that is cube over cube assembly. So all of you know that in this assembly we want to apply the load here at the center of this top cube, and we want to constrain the bottom face of this second cube. Now here you can see the schematic of abstract model file in context of cube over cube assembly. So you can see here we have used some classes, that is load, solid, fixed 2D, and we have just represented some attribute with these triangles, and we specified it on the classes or the relation between the classes. So likewise we have captured the physics related to cube over cube assembly. Also we have used the model or the global class to specify some attributes, that is some attribute related to mesh, material and the length scale factor. So this is the abstract model schematic. Let's now see the CAD model. You can see here I have opened the 2 cube assembly in Creo, and you can notice some tagging is done here. So solid class is assigned to block 1 and block 2 part, and load class is assigned to the wedge part. You can notice that we have assigned a single class to each component, and these classes or the naming of these classes is in line with or same as that of the classes which we used in our earlier example, that is the coupling model. So this is from the CAD modeling point of view. Let's now see the details of abstract model file. You can see here I have opened the abstract model file. Now this abstract model file is the same abstract model file which I had used for the coupling assembly. So it contains the same classes, same relations and all the attribute same as that of we used for the coupling assembly. The only change we did it in problem definition tab, that is for this point force attribute we used unpruned 1D of Ri relation between load and solid class, and in the attribute we specified the geometry reasoning method. The reason is for this cube over cube model we want to apply the load at a single point, and that's why we use this abstract entity or this relation, and we have used the necessary geometry reasoning method. Whereas in the coupling model we wanted to apply the load on the surface, that's why we had used the relation between load and solid there, so that we can get the corresponding surface and we can apply the load there. So this is the only one change I did in this abstract model file, and with this we'll just create our simulation model now. So I'll just select my 2 cube assembly. After that my simulation model will get ready. So you can see here this is my simulation model. All of you know that for meshing one need to click on this icon. So you can see here my mesh is also ready, and after that I'll just carry out the export of my input deck. I will just select this folder, and you can see I have done my export. So what we have done here is for this 2 cube assembly also we assigned a single class to single component, and we use the same abstract model file which we use for the coupling assembly. We just modified one attribute there as per our requirement, and we could use the same abstract model file for this model as well. So you can see here we could achieve this automation without any scripting. So we just created an abstract model file for coupling assembly. We just modified one attribute for this 2 cube assembly, and we could just create the input deck for both these assemblies. So this is the automation we could achieve with the help of this approach, that is one-to-one abstract model file creation, where we just assign a single class to single component and we use those classes to create the abstract model file. Now, this one-to-one approach is not the best way or is not the effective way of using abstract modeling technique. So for example, in this approach, we created one attribute, that is number of nodes, and the reason is we wanted to have the number of node is equal to 1 at these 4 locations. But what if somebody wants to define a contact pair attribute at this top 2 location and number of node is equal to 1 these 2 bottom locations? So that is not possible with one-to-one approach. We can still do that, but for that we will have to add a separate classes to each part, that is solid 1 to solid 4 will have to add against each part, and this is not the good way of doing tagging, or we can say this is not the practical way of doing tagging. because if we do the tagging like this, then we will end up in creating lot of attribute. For example, we want the number of nodes here, so we'll end up in creating two attribute. We want the contact pair at these two location, so we will end up in creating two contact pair attribute, and we'll have to create these four attributes for solid. So we will end up in creating lot of attribute if we decide to capture the physics with the help of one-to-one approach. So in next tutorial, we will see what is the best way or what is the efficient way of using abstract modeling technology. So we will see the many to one approach which will enhance the automation capability and reusability across different workflow. So with this, we are done with one to one approach. If you guys are having any question, then please feel free to contact at support@novusnexus.com and we'll get back to you accordingly. We will now meet in the next tutorial. Till then, have a good day. Bye.